Beginner series, advanced courses, and everything in between, CAD Junkie brings you the best in Modo, SolidWorks, and Rhino video training ever. On the face of the earth. Ever. Get your premium membership and a leg up on your coworkers at cadjunkie.com.
Josh, if engineering were a red-eye flight, you would be the middle seat between two crying babies with exploding snot bubbles and a dead iPad battery for 5 hours.
And you would be the microscopic bag of complimentary peanuts. Welcome to Engineer versus Designer.
The podcast.
For engineers,
product designers,
and people who bring CAD to the masses while juggling chainsaws and impersonating Mick Jagger. Yes! My name is Josh.
And my name is Adam. Each week we'll bring you the freshest product design juice squeezed straight from the lobes of our esteemed guests.
This week we'll be speaking with Kai Backman, former Google engineer and founder of Tinkercad.
Oh yes, Tinkercad, people. The web-based 3D modeling tool that's enabling everybody from 8 to 80 to easily produce their own 3D printed designs.
Finally, I can teach my mom and dad how to 3D model over tea and crumpets while listening to Neil Diamond in the Rose Garden.
Excellent. All right, well, Kai, welcome to the show. Our first question for you, if you could invent the world's first instant donut printer, but in order to do that, you had to eat donuts every day for the rest of your life, would you do it?
Ooh, that's a hard one.
Oh, that's hard? Go on.
Well, yeah, I mean, it's pretty clear that eating donuts for the rest of life is so cool, but everybody else would be very jealous of it. I do think one would have to do the sacrifice for something as awesome as a donut printer. I would take the jealousy of the world for the rest of my life, just so I can introduce something so cool. Yeah, definitely.
Very good choice, Kai.
A worthy sacrifice. A worthy sacrifice.
Way to sacrifice for the team. And speaking of extruding fried dough into our mouth holes, Josh, roll our brains in powdered sugar and inject them with the raspberry filling of knowledge. What do you have for us this week?
All right, today we're speaking with our special guest, Tinkercad founder and coding bad boy supreme, Kai Backman. Kai, now, before we get to the fast and dangerous side of 3D modeling in your underwear while listening to Bob Ross reruns in the background, you were previously a coding mastermind at Google working in the docs department. Is that correct?
That's correct. So,
is that true?
Yeah, I was at Google for 5 years.
So what part of Google Docs were you working on?
So I worked on the backend side. I was basically running the team that did the backend stuff. So all the front-end applications sit on this huge infrastructure piece. So I was hidden. I keep joking that the only time I made the New York Times was when we had a really, really bad outage. But other than that
right.
nobody knows about me.
Well, we live on Google Docs, so
you're not the only one.
Reading from one right now. So, we'll be getting into the nitty-gritty brain-bashing goodness in the next segment, but real quickly, Kai, how did you make the jump from working with something like the back end of Google Docs to 3D on the web?
So, I was really scratching my own itch. I finally got it. I love 3D printers for a bunch of years. I've been following them, but they were too expensive for somebody just like, tinkering around with them.
Right.
But finally, in 2009, I got a working 3D printer. I've been trying to build one for several years, but very little success, sadly. But, I bought a ready kit. I think it was a MakerBot at the time. It was super, super excited. Only to figure out that I didn't have the time, really the skills either to learn any of the existing Solid programs. Like, I tried to use something that like normal 3D programs, but the geometry they gave was not printing on the printer. And then I tried to learn something like SolidWorks, and my brain just melted. It was also I didn't have time for it, so I complained about it. Right, so I complained about it for a year, and then I realized like everybody else was complaining, and figured out might actually do something about it.
Yeah, there got to be easier ways. So what sort of things were you trying to print when you first got started?
Oh, I was trying to impress my wife and kids, so I was planning on printing. Planning on printing tons of cool jewelry and toys. But as with the previous question, it didn't really end up impressing them much when we had this thing that outputted goo and not much else.
What is
that? Well, and actually, we didn't let you get your plug in. So before we go any further, Kai, what is Tinkercad?
Oh, right. So we're the most advanced solid CAD tool in the world. We're obviously, because we're really new, we don't have that much features, but we're actually kind of a generation ahead of the existing desktop tools and stuff. A side effect of that is that we're super easy to use. Because the technology is so kind of a generation ahead of the kind of existing desktop stuff. We've been able to make something that's super accessible for everyone. So it's
and completely web-based to boot.
Yes, exactly. Yeah. No installs required.
Oh, okay, so now back to 3D printing. One last question on that topic. What is the most absurd thing you could ever dream of 3D printing?
So, I think it must be houses. There's, houses, seriously.
Yeah.
I mean, like, all the small stuff I can understand. My kids understand 3D printing is magic, obviously. They think the 2D printer is magic. They're amazed every time something paper comes out of the device. But, 3D printing is like mainstream. They don't think it's the toy machine, right?
Right.
But for me, it's magic. But, I can stretch my imagination to think of printing small things. But the fact that there's the Italian guy who's printing houses, that just blows my mind. That's not right. You're not supposed to print houses. That's not possible.
Enrico Dini, yeah.
Exactly, yeah.
Okay, now Kai, you're somebody who found a lingering problem with the CAD industry today and actually created a working solution that's a real thing. So we're going to discuss an idea and the possibility of that idea becoming a reality.
Yes, it's true. Our question for you, Kai. We think you should make a new primitive in Tinkercad for Batman figurines, okay? You can make big Batman, small Batman, fat Batman, skinny Batman, like Adam likes to dress up like sometimes. The possibilities are just endless, right? So what do you think about that?
I think this is one of our best ideas ever, play nice.
So let's start off by I'm so impressed. I'm speechless. So
impressive.
to be honest, it doesn't. Right.
I really appreciate Kai's positivity, and we'll definitely be talking about the licensing rights to this idea with you later. But I think this does bring up a bigger discussion about the future of web-based CAD programs. I mean, there's Sunglass.io and GrabCAD. They're both great sites, but they don't allow you to actually build anything from scratch. Tinkercad, as far as I know, is the only web-based solution right now that actually lets you build stuff in 3D on the web with no install. Yeah. So where did this start, and where are you along the journey, and where are you heading?
Right. So we knew from the start that we wanted to let people create stuff on their own. I mean, I think the web is really powerful for getting content together, but we really didn't want a content aggregator. We wanted an editing tool, something like that actually could build real things. And we could have built a desktop application, but the web nowadays just makes it possible to build much cooler applications that you could ever build on the desktop. When we knew we wanted to build something, a real solid CAD, we basically started tackling the really hardest problem first. So we started by going down to the geometry kernel and figuring out how we could actually build a cloud-based kind of distributed large-scale geometry.
Wait. Hold the phone. You build your own geometry kernel?
Well, that's actually not true. We built 6 of them, and we found a way.
No!
Because one's not good enough.
No, seriously.
This is a solid-based geometry kernel?
Yeah, we built 6 solid geometry kernels, like Parasolid or Asses. We keep joking that we throw down more kernels than there's commercial kernels available out there currently.
It's just not true.
So,
that is excellent.
Generation 6 looks good, though. Like, we hit the sweet spot where we have something that's that basically has 2/3 of the features of Parasolid or Asses, but has magnitudes more power because it's distributed. So we're at the point where the stuff you see today on the site, it's really the tip of the iceberg. There's a lot of stuff we needed to make happen to even make the easy stuff you see today. But the next few months, years are going to be really, really exciting.
Wow, that is phenomenal! I had no idea.
It seems like you're really focused towards 3D printing and small sort of maker hobbyists right now. But are you going more for the bigger fish?
Right. So we started out with the maker segment because they had a clear need. So they're the people who didn't have an easy to use SolidCAD that they could actually use. But if you look at the technology, it's all the big CAD tools are going to have a kernel similar to Tinkercad's like 5-10 years down the road. It's just the change is happening right now. So just to give you an idea, like if you run something like Parasolid or Asys on a 16-core system, you're not going to be able to use more than 6-7 cores until it becomes slower. Like if you run Parasolid, I think on 9 cores, it's slower than if you run it on 6 cores. For Tinkercad, the same number is I think 1,000 cores now. And we're pushing it out all the time. We have our next kind of few changes going to push it up to 5,000 courses. So we can use a supercomputer to do the same computation that you do.
Now, I mean, we've had the Sunglass.io guys on the show before and talked with them about what they're doing on the back end and how they're using Amazon servers at the moment and doing a lot of big heavy lifting in the cloud. And you guys are doing similar stuff. How would you compare what you're doing with what the Sunglass guys are
Right. I would say that I think the difference is a few magnitudes of order. So the Tinkercad you see today runs on, I think, 100 machines or so. So there's actually a sizable cluster backing it already. And the difference is mainly that if you just aggregate stuff or do stuff, present stuff, it requires like 10 or 100 times less resources than actually doing the modeling part.
Wow.
The geometry kernel part that's the really, really hard problem. That's like the compute intensive. I keep joking, I worked at Google on some of the biggest systems on the planet, and I think the CAD problem is bigger than most of the problems Google has.
That is mind-blowing. And speaking of mind-blowing, stay tuned because next week we're going to discuss Josh's new helmet-mounted blender.
I can't believe
Will it blend?
Yes.
Will Josh
Yes, it
blend?
will.
He
Yes, it
will indeed.
Yes, it will.
Welcome back, EVD listeners. Today we have the great pleasure of speaking with the man on the CAD to the masses mission. His company, Tinkercad, makes the raddest, baddest 3D modeling hotness that's ever punched your browser in the face. His name is Kai Backman.
We wanted to have Kai on the show because he makes CAD useful to people who don't have a design or engineering background. And traditional MCAD tools are about as approachable as a 1 million piece jigsaw puzzle.
Welcome, Kai. First, enabling people.
Yes.
You have enabled a lot of people to start making 3D prints who would never have been able to build stuff without Tinkercad. I mean, where did this... You've talked about wanting to make stuff accessible to people, and you talked about wanting to make things for your wife and kids. But why? Why is 3D printing important to you?
So, in some sense, most of the users are a bit like... I mean, I see the problems I had originally when I started Tinkercad is what most users have. They usually almost all our users have something they're really good at. We've been talking a lot of makers, but we have other segments which are really interesting. There's one of them which is a very tiny one, but fascinating is like lab scientists. So if you're a lab scientist, you're basically trying to solve totally unique problems. There's a very big chance that what you're trying to do has never been done by anybody else. That's kind of the definition of science to start with. So these people often have tiny problems, but problems that from an engineering standpoint are tiny, but from their perspective is blocking their job. And in a lot of cases, a simple 3D printed piece would help them, continue with their work. But it's so small that they don't want to go out and contract an engineering company, and also they definitely don't have time to learn something like a high-end CAD package. So what we're doing is we're enabling these people, who are in some sense professionals in their own field, or definitely professionals in their own field, solve problems that are, but the fact that Tinkercad is so easy to get into, they can come in, fix their problem, make like a little microscope mount that fits their microscope, their specimen sample they're trying to analyze, and, get on with their day.
So do you get feedback from customers telling you that they're actually using Tinkercad to make things at work or to make things like a microscope mount?
Oh yeah, that's a real example. We have a bunch of them on the site. So people are basically like all the I mean, makers in some segment are a typical example of this. They just happen to be consumers. That all of them have some weird problem they're trying to solve, and they just want to go in, quickly solve that problem, and go out. The lab scientists are more like a professional segment in the sense that they're like real people doing real work. But in the end, they look very similar. They want to go in, they want to kind of design their piece quickly, have it 3D printed, get on with their lives. So I think that's the part that gets me up in the morning is enabling all these people to. It's a very small thing, but enabling all these people to be better at what they're already doing. Like Google kept joking when we were at Google. We kept joking that Google wants to be the page that nobody visits for very long. That you come there, you type in what you want, and you go out. In some sense, Tinkercad. We want you to.
That is cool. Now, we know you were at Google before starting Tinkercad, helping handling the Google Docs backend and all that. But how did that experience at Google help shape your next adventure in developing this CAD-based web tool?
I think one thing that's hard to...
One of those.
Right. I think one thing that's hard to say from the outside is that Google engineers end up thinking very differently than people who've done, for example, desktop software or small sites. When usually you think on a handful of machines, perhaps 3-4 machines. At Google, when you had a hard problem, the first question was always, how could I use 10,000 computers to solve this problem? Like, if I had a lot of resources, how could I use those resources to solve the problem? And it turns out a lot of problems become very different when you start out with the mindset. When you have the mindset of let's not make it work on one computer. Like, how could we make this, this operation that used to take 10 minutes, how could you make the operation take half a second using 10,000 computers? And, that's what we started out with the geometry kernel work and everything. We approach it the same way you would approach at Google. Like, the world we're getting more and more computers at our disposal. How could we ride that trend? How could you make sure that when people have, like, a small company might have a rack of servers that's like 10,000 cores on the rack, how could you make it so they could make you have a CAD tool that would be really powerful on that setup? Like, how can we write that specific way? I think that's probably the biggest magic that
what would you say Tinkercad does really well right now? And on the other side of that, what would you say it is maybe lacking or could do better?
I think the big thing we do well is we let people get started so quickly. So, I mean, there's two things you need to learn, really. It's like you drop shapes, some of those shapes have colors, some of those shapes are holes, and then you need to learn to group so that once you group, you get a new shape and you can reuse it, like, build hierarchies of shapes. And once you learn that, you basically know Tinkercad. I think we're definitely lacking in the feature side. There's a bunch of cool things we haven't released yet. We've just released import, which is a huge thing. You're now able to import, like, arbitrary things into STL files into Tinkercad, and they will just magically turn into real solids. That's a huge step.
Wow.
We're definitely missing on the feature side. There's a bunch of very requested features. We don't want to solve them feature by feature. We have some plans for making it possible for people to build stuff like plugins, so they could build their own tools, en masse, instead of having to rely on us to build specific tools for them. But I think getting started. I mean, import is a big step in getting more easily started. The fact that you can, it's I don't know. It's a few high-end packages that even support, like, seamless import of bad geometry and turn it into solids. But we really can take in pretty much any crappy STL file and have it work as a real solid object in Tinkercad.
Now, we've seen a lot of excellent examples of what can be done posted on the Tinkercad blog. What are a couple of your favorite projects to date?
Oh, there's so many. So two I like a lot, which are really cool, is the Brewster Station by Emily. She's a graphics designer. It's like a historic train station on the New York Harlem line. It's amazing because it's a very complex model, and she never used CAD before. She did stuff like she made every individual brick into her own thing, which is why you're not supposed to do stuff like that. But she didn't know, so she just did it. The other one is Arian's tabletop games, but he's done like tons. I think 3-4 different games at this point. But to be honest, my favorite piece is a piece done by my 3.5-year-old daughter. That's basically, she made her own bunny toy, and That's just like
Is that the one on the homepage?
no, that's actually done by one of our engineers. I think if you go to my profile page, you're gonna find the bunny. But the bunny she made, that's it's hard to beat that. There's like that's hard. There's a soft spot in that's hard for that.
I can imagine. Now, I mean, clearly, you must have had a really talented team backing you up with the development of such a huge thing as building a kernel, much less 6 of them.
Exactly.
And plus the front end on top of it. How did you assemble this team? And what sort of process did you guys use to get this team up and running?
Right. So I've been extremely lucky with the team. So just to give everybody a scope, like this is Tinkercad is a team effort. Like I'm a very very small and insignificant part of the whole. So my co-founder Mika, who we started a company with, I basically known him for 10 years, and he has a very complementary skill set. So whereas I had a like long background distributed systems, kind of 20 years over 2 decades of doing kind of that type of work. He has like 2 decades of working with geometry, computational geometry and stuff. So we had really good skill sets. We keep joking that we've been practicing for building this product all our lives. So we just happened to be in the right place in 2010. And we always wanted to do something bigger, and we sat down and thought this would be the problem we actually like go through. But most of it is just very very hardcore software engineering. Like I think the average experience for most of our engineers have several decades of software engineering experience. Most of it in really really high kind of very difficult, solving very difficult problems. I think our junior engineer only has 10 years. He's like yeah, right. He's like the guy. He's only worked on systems with like 1 million users on it. So he's a rookie in the team.
You say you have an insignificant contribution, but I'm sure you do a lot. You wear a lot of hats there, have many jobs. What's the favorite part of everything that you do?
I think that in the end, what gets me up every morning is seeing what like users are doing with the tool. It's like in the beginning it was obviously just us doing modeling when we hadn't released it, and after we released it for a while we were still the team was doing the most models like for the first week or so. But nowadays it's just every time I come back there's people who done stuff I didn't expect was possible with Tinkercad, and in many cases I didn't expect was possible at all. So that's just mind-boggling. It's like it gets me up. Like I want to make sure that those people like get more tools at their disposal so they can do even more cool stuff.
Now, I'm really interested, as an industrial designer, a big part of what I use CAD tools for is kind of complex surfacing and difficult cosmetic exterior surfaces. Clearly, that is a huge task and a long way off probably for Tinkercad. But I'm just curious, are you guys hoping to become a real full-featured CAD system that could do that kind of work? Or are you hoping to stay more in the realm of hobbyists and makers?
Right. That's an excellent question. So we think part of the magic that's happening is that because the kernel is so much more advanced, I think we're going to be able to keep the really simple, the base Tinkercad as it is. There's obviously a lot of people who would like stuff like NURB surfaces and more things like that. For us, we want to enable that type of modeling, and as I look at the product roadmap, it seems like we would be able to let people do more advanced modeling, for example, with NURBS, while still keeping the really, really kind of core functionality. I mean, in some sense, it goes back to if you think about a product like an iPhone or any of the smartphones, where it's the core product is really simple to use. But you have this ability of buying apps to extend the product to do pretty much everything. Like there's like a heartbeat monitor, and there's I think there's an oscilloscope for the iPhone, and there's all these weird, really specialized apps. So I think we're definitely gonna go down that road where you have the basic experience is really quick to learn. But if you want to go down on some specific avenue, then you can basically like download an app for that and specialize the tool. So I'd love to see a NURBS app at some point. Either made by us or made by somebody else using an API.
Now, I'm just curious, do you, Kai, actually know how to use a CAD system other than Tinkercad?
Oh.
And if so, what is it?
Right. So I've actually I've used a bunch of 3D systems in my. So I used to do a lot of game stuff 10 years ago. So I used like classical surface modeling stuff like Maya and 3D Max and so forth. And then I've used stuff like SolidWorks and you know I used a lot of Rhino, which is kind of in between a real CAD and a surface modeler. But mostly SolidWorks and then I'm probably missing something else. But yeah, I've actually used real CAD systems. I wouldn't consider myself a professional in them, but I understand enough about them to kind of be dangerous, so to speak.
Well, pretty dangerous, I would say.
Yeah. Very cool. You guys have a strong Maker Faire background. You've been to quite a few with MakerBot and there. So wondering, what is your favorite part of Maker Faire?
Maker Faire is just fantastic. I think in a way I still can't get over my first Maker Faire. I mean, it's the ones I've been probably to 5 or 6 by this point, and we gone to several as Tinkercad. But I think the first time I went, obviously, for people who haven't been there, it's this like crazy place where there's millions of things happening. I remember walking in the gates and you know feeling a very distinct kind of emotion of wow, I'm home. Like this is the type of people you know, this is the type of stuff I've been doing all my life. It's nice to see that I'm not the only one. And in some sense, I think that's you know that feeling of wow, there's a lot of me's out. You know, there's a lot of people with similar kind of ideas out there. You know, not ideas, but similarly wacky people out there, which was really it was comforting. You know, Mom might have been wrong. I was probably not as like crazy as she thought at some point.
So, are we going to see you at Maker Faire New York?
Sadly, we're not going to be able to go this year. We're actually going to. It's a big disappointment, but we wanted to go, but it turns out that it's conflicting. We have a big announcement we can do later today.
So there you go.
There you go.
Wait, but later today?
Yes.
This isn't coming out until next week. Tell us now.
Oh, right. So what's actually happening is that we're moving the headquarters of Tinkercad to San Francisco, and that move just overlaps with the Maker Faire, so we're not able to actually go to the fair this year. It's mainly that we have a lot of really dedicated US users, and we wanted to be closer to those users and basically be able to work closer with them. So sadly, the move overlaps with Maker Faire.
Very fun. Well, unfortunately, we're out of time. Thank you so much, Kai. Having you on the show has been even more fun than that time Adam accidentally ate a pile of brown crayons, thinking they were novelty chocolates, then regurgitating them and melting them back into one giant crayon.
Thank you so much for your time.
Okay, fair enough. I have kids. This is a fairly standard procedure.
If you'd like to send giant brown crayons to EVDHQ, please regurgitate them and send them to Josh. You will enjoy coloring within the lines with those regurgitated.
Yes, always, I will. And if you would like to send your old Alta Sax to EVD, please address those to Adam/Smalley. Yes, we love your lack of comments. Please continue to not leave them. Leave them, please, at EngineerVsDesigner.com.
And if you'd like to find out what brand of power tool Josh uses to give himself a pedicure, please be sure to like us, +1, tweet us, or whatever else, as social media has been correlated with overdoing it for the sake of beauty.
So true. This show is edited by Simon Martin. Our theme music is by the Red Hook Ramblers.
We'll see you next week. And remember, you can pick your friends and you can pick your nose, but you can't pick your friend's nose while tap dancing.
There it is, tappity tap.
I knew.
Learn how to create complex surfaces in SolidWorks, tricks to tap the depths of Modo, video training that takes you further into the software and gets you up to speed faster. Sign up for free, grab a premium membership, and get the best training. CADjunkie.com.
A production of EBD Media.